What is going on, everyone? Happy Sunday. It is the end of spring break, and I am forever heartbroken about that. I'm going to talk about unordered maps and the string stream library today. Gotta get some music going first. Do not copyright me. Lab this week is covering two new things, the string stream library and the unordered map library. Unordered map is from the STL. It is the equivalent of a hash table or a dictionary in Python, and I just want to make this video kind of showing it off and playing around with it. And then I'm also, despite my big desire on not teaching you all anything, we'll be talking about the string stream library also. So for unordered maps, they are dictionaries. It is JSON key value pairs. So very first thing we're going to do is to pound include unordered map. That's it. And that will work. So now that we have it created, we want to make our unordered map. I do have Copilot on, so I am kind of cheating, but it will be an unordered map, and then we have two square brackets and whatever we call it. That's not a square bracket. I'm lying through my teeth. Alligators. So with everything that we've used from the standard template library, it is templated. And unordered maps are the exact same way. However, it is double templated. So with a unordered map, the inside right here is going to be doubly templated. So it will be the key, or the data type of the key, and the data type of the value. So data type. And then to start off, let's just do an integer and an integer. So this will take two integers. The first integer is its key, the second integer is its value. And so if we come down here, we can start playing around with it. I'm going to go ahead and add a couple. And if you will notice, it is two curly braces. This basically says, hey, I'm adding an array. It's not the arrays that we know, but it is multiple key value pairs. And then we'll get it started off pretty simple. We'll say 1, 1, 2, 2, 3, 3, and we'll call it a day there. So now that we have our key value pairs inserted, we just want to check and make sure that everything got added correctly. So there are a couple of different ways that we can loop over an unordered map. The easiest is going to be using a for each loop. Now you can do all of this. I'll show you it here in a second. But all we're going to say is for auto mm, and then as you can see, this autocomplete kind of tells us cout I dot first, space, and I dot second. Can I make that go away? Yeah, that's what I wanted. Be gone, Copilot. I want to be smart by my own. What am I am... There we go. What we're saying here is to loop over mm, and for each key value pair, place it in I, and then we're just going to cout. Let me go ahead and get that cracked open in my terminal. Make it large. We're going to do g++ map.cpp and run it. And as you can see, we get our key value pairs out. So 1, 1, 2, 2, and 3, 3. The other way that you can loop over these is by using iterators. I know they are so much fun, we just want to use them all the time. So just like working with the STL lists, We specify we are starting at the beginning. We are going while the iterator is not at the end. And then for each step, we are going to increment it. From here, we would see out I arrow first, because if you remember, iterators work like pointers, so we need the arrow operator instead of the dot operator. As space, and then IT second. We add a little bit of white space and run it again. And as you can see, we get 3, 2, 1, 3, 2, 1. So both of these are valid ways of looping over it. One is definitely easier and a lot less to type. So now that we can print these, I'm actually going to go here for it. I want to start adding to my map. So we're going to do two different ways to do it. We can do, I don't want to say the intended way, but the like nice and professional way of doing it is going to be mm.insert. And then inside the parentheses, we do curly braces. And then we can specify whatever we want to add. So 5, 5. The other way we can do it is array notation. And we will do, I haven't done 4 yet. And we say at 4 is equal to 4. We're getting really creative here. So we can run it one more time and we can see, hey, this stuff got added. One thing I do want to point out is that it is a unordered map, meaning it's not going to be in order once you start adding stuff. So now that we have played around with them as integers, I want to start mixing it up a bit. I'll keep that. So instead of a int and a int, I want to do an int and a string. Now we need to go through and change this. We're going to say first, second, and third. From here, I don't know why I uncommented that stuff. Let's go ahead and check, make sure it works. 3 third, 2 second, 1 first. That is awesome. It didn't magically break in the time that I went from practicing to recording. So, showed off insert. Let's say we want to get rid of something. You know, we messed up. We have to get rid of it. So we're going to do mm.erase. It's ugly. If you do .erase and tell it the key that you want to delete, it will get rid of it. So we go from 3, 2, 1 to just 3, 1. That is pretty cool. But it's like, okay, we have our key, we have our value. What's the use of this? What we can actually do is pretty cool. So let's... I'll save that for later. So this will work with essentially any data type that you have. You could do an abstract data type, you could do a class, you could do strings, doubles, ints, files. I know I always say files and never show them off. There's a reason. So let's change this to string and an int. Let's do 2 strings. I don't know what I want to do. Wrap these in double quotes. mm.insert, passing in 4, 4th. And then we will, for auto I in see out I dot first space I dot second. And as you can see, it still works. One thing I did notice when I was playing around with it is that if, so it is the STL library, meaning that anything that we've worked for basically works here, including the vector stuff like .at. So if we do mm.at, we'll print it out at first. Mm at 4. Compile and run, we get 4th. So that works, that's awesome. What if it is not in our map? Just like vectors, it's going to throw a out of range error or out of bounds, whichever you want. But it's saying, hey, this does not exist. I don't know what you want me to do with it. And if you will recall, whenever we work with array notation, it doesn't have that same sort of security. So if we do cout mm at 5, nothing comes out. It doesn't tell us it broke, it doesn't do anything, it just says, hey. So I'm going to uncomment this, and what I want you to notice, this is actually weirdly cool. Whenever we use array notation and it doesn't exist, it adds it in without a value. So if we do cout 5, it adds 5 into our key value pairs, I guess just key. And so if it doesn't exist, it creates it. I think that is kind of cool, kind of quirky. Don't know why it'd ever be useful other than breaking things, but it is something you can look at. So, talked about looping, talked about inserting, removing. Unordered maps are kind of cool. I was looking into them a little bit, and one of the big things was word frequency counters. I'll talk about string stream first and then talk about it, but it was pretty cool. So moving on, talking about string stream. This is one of the libraries that I've always been hesitant about teaching. If you have played around with any of our generative overlords, they love this library. And with good reason, it's a cool library, I will not lie. So to use it, we're going to need #include s_stream. And the general idea of it is that whenever we work with input or output, whether it be through files or just user input, it works with I won't just say a certain way, but you have your cins, your get lines, and all of that works. What this allows us to do is work with strings as if they were a stream, but they're still a string, if that makes sense. So normally if we work with strings, my string is equal to something funny and quirky. You have to... You didn't see that. Normally you would have to do something along the lines of, if you want to find a word or sort of iterate through it, we have been normally doing characters. So I is equal to 0, I is less than my string.size, and I++. And then we can see out my string at I. And so normally whenever we're working with these strings, this is how we're doing it. We're working character by character instead of word by word or chunk by chunk. And so let me go ahead and run this just so you can see. We get something funny and quirky, all on separate lines. So this has been the normal way that we've worked with strings. It is not efficient, it is not beautiful, it's something, it's a way to do it. So with the string stream library, it actually allows us to work with it like it's actual input, or from a stream. So let's go ahead and make a new string stream. I will call this hee. And then it does take a string in its constructor. And we're going to put my string. And from here we get to work with it as a stream, basically, for lack of better terminology. So I need a temp variable. We are going to say he. We're going to do alligators like we are doing cin or file in, and put it in temp. Next, we are going to output what temp is, compile and run, and we get the first word out of our string. So whenever we treat it like a stream, we can use the cin insertion operator, and it will grab the first chunk, up to the first white space, I should say. And so what that allows us to do is to say while he can grab input, we're going to cout temp, and we get something funny and quirky, ignoring white space. So I believe this will work with getLine also. So if we specify getLine from he into temp, comment that out, cout temp, this should grab everything from it. Something funny and quirky. So you're probably sitting there like, Brandon, okay, we can loop over words. That's so cool. I do not care. That's fair. But let me go and find this real quick. I threw this into the given with your lab. Go ahead and get this open. Almost there we go. So I built this combining unordered maps and the string stream class, library, whatever you want to call it. And so what we're going to do is we have a unordered map that takes in a string and an integer as its arguments. So the key is going to be the string, the value is going to be an integer. We crack open words.txt, it's just random stuff I threw in there. We grab the entire file. I did structure it to be all on one line. Print that to the screen. Next, we make a string stream object, passing in the words that we just ran from the file. And then this is the cool part. We can use it for word frequency. How many times does a word show up in text? So while there is still words to grab from string, think of it just like a file, while there are still words to grab. We check to see if it is in our map or our dictionary. If it is not, we insert it, and if it is, we increment. Look at that. That part of me loves it because it's like, oh yeah, we're starting getting like Pythonic area of like, oh, throw it all in one line. It's so ugly. So we go through, we count how many times do these words show up in our text. And then finally, we print it out. So for auto, first and second, so everything we've seen. So let me give that a compile, make it a little larger for you. Word.cpp. So the complete text is, there's a simple joy in being a dad who just wants 3 things in life: to crack open an ice-cold Monster energy drink, slip into a comfortable pair of jean shorts, and fire up that mower when the grass hits that perfect needs-cutting height, and a bunch of other stuff. And so we can look at the amount of times that these words show up. So it shows up. Where did it go? It shows up twice. We have wife shows up once. I shows up 3 times. Of shows up 7. Debating, fire, a. And so we get this word frequency chart. We have my, capital M, my. So there are a couple things that it does not directly cover. If you wanted to build this and only look at the words, it considers uppercase letters and lowercase letters different, so those would be separate keys, as we saw with my, capital M, my, and lowercase my. and it also does not exclude punctuation. And so if you had basic and basic comma, those are two different things. So, yeah, more or less just wanted to spend a little bit of time showing map off. These are given to you with your lab map showcase and word.cpp. And it's just different ways of working with it. Just different ways, what to expect, things like that. So, in case you all missed my beautiful, beautiful voice over spring break, here's a video for you explaining it. And yeah, if y'all have any questions, feel free to reach out. I will try my best to answer them. The reason why I think these two are really cool libraries, with a lot of the other stuff we've covered, such as STO list, stacks, queues, it's like, oh yeah, that's something. Maybe my brain's just like wired differently, but I do like unordered maps and string stream, S stream. So yeah, nice little 20-minute video for you, probably 5 minutes of actual content in this. I hope you all have a wonderful whatever time of day it is, and take it easy.